Nuclear power plants are thermal power stations which generate electrical energy from heat. They consist of numerous buildings and facilities, the most important of which are as follows. The turbine building houses several turbines as well as the generator necessary for electrical power generation. The containment building where the nuclear reactor is housed is made of meter-thick reinforced concrete. Inside this building, nuclear reactions take place where water is heated up. The cooling tower, which can be as tall as 200 meters, is where hot water is cooled. In order to easily understand the underlying principles, the following is a description of the most important components of a nuclear power plant that uses a pressurized water reactor, PWR. In the reactor pressure vessel, the nuclear reaction and the associated release of thermal energy takes place. In a pressurized water reactor, as in this case, the reactor pressure vessel stands about 12 meters tall. The walls are about 25 centimeters thick. Inside is where the fuel assemblies can be found. In pressurized water reactors, about 150 such assemblies are installed. A single fuel assembly is composed of many fuel rods. A fuel rod is about 5 meters in length and has a diameter of about 23 centimeters. The actual nuclear fuel is found inside of each fuel rod. Small nuclear fuel pellets composed of enriched uranium or plutonium make nuclear fission chain reaction possible. In the fission chain reaction, thermal energy is released. Water is needed in order to absorb the thermal energy and keep the chain reaction going. Inside the vessel, the water is heated to over 570 degrees Fahrenheit. The water does not boil, however, since the pressurizer maintains the water pressure constant at around 160 bars. The heated water is eventually pumped to a heat exchanger, also called steam generator. These are typically in the form of a shell and tube heat exchanger. Hot water flows through the U-tubes, heating up the metal of the pipes so that any water inside the heat exchanger begins to boil. The resulting steam is eventually fed through a set of pipes to the turbine building. The steam first drives a high-pressure turbine and then is typically fed to 2 low-pressure turbines. All of the turbines are connected by a spinning shaft to the electrical generator, which in turn produces AC electricity from the shaft's rotational energy. The steam is converted again into liquid form in a condenser, and then returned back to the steam generator. The water needed for this often comes from an adjacent river, or is cooled in a cooling tower. The water circulation systems are always kept separate from one another. Water in the primary circulation system never leaves the containment building. This water is radioactive, since it has been in direct contact with the fuel rods. Water in the secondary circulation system is used to drive the turbines and is not radioactive. The cooling circulation system provides cool water and is used to condense the